Okay, today we're going to talk about your ears. Yes, in fact, they do more than frame your face. So here's what an ear looks like. We're not going to worry too much about the anatomy side of things, but we are going to look at it from the engineering side because most of the time when you're measuring sound, you are just using your ear, and it's important to know what it's doing and how it works. That way you can understand how sound interacts with you because it's similar to a microphone. Okay, so let's look at this wonderful picture. This part right here, this is your outer ear. Your outer ear is just pretty much a frame. All right? Your ear is shaped this way to help focus the sound into your ear, but the outside part doesn't really have anything to do with your perception of sound. Okay? And here you have some earlobes. You can attach them or detach them depending on your genes. Okay, so over here in this general area, we have your middle ear. Your middle ear has this thing, which is your auditory canal. This is your ear canal. This is where all your wax likes to live, for example. Okay, towards further into your ear canal, you have your tympanic membrane. This is also known as your eardrum. Okay, so basically remember when sound wave comes in, when it comes in, what happens is it's focused to come into your ear canal. And what happens is the same thing in reverse of the drum we talked about yesterday. So the waves hit the eardrum vibrates back and forth. Okay, that's what the goal of the eardrum is. The eardrum vibrates back and forth because it is a thin film, just like if you held up a piece of paper and you blew on it like whoosh, 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 you would get it to vibrate. And then that's what's happening inside your ears right now, even as you hear my voice. Now, this vibrates and it hits these three very small bones that have very complicated names, or the ones that I remember, which is your hammer. Do you remember these? Your anvil and your stirrup. Do you have to remember these names of these bones? No, it's not important, but you probably learned them a long time ago. These are only going to vibrate. So these are vibrating because your eardrum vibrates. So because this wiggles, these are going to wiggle as well. And this helps focus the vibrations to the next point of your ear. Okay? And that's how this works. The next part of your ear, we're entering your inner ear now, is your cochlea. Right? We're jumping down here to your cochlea. Your cochlea is this snail-shaped thing, all right? This spirally thing. Now, inside your cochlea, we're going to look at this in a second here. You have a bunch of hairs, which have a name that I don't remember because it's not important right now. Now, these hairs have different lengths. As you go further in, they get shorter. Now, these different lengths correspond to the vibrations. If you have a bigger vibration like this, it's going to vibrate a hair that's about that long. Now, each one of these is attached to a nerve. The nerve is connected to the auditory nerve, which goes back to the brain. Maybe for some people this is actual sized. Anyways, the brain interprets which one of these places in your cochlea gets vibrated, and it changes that into an actual sound that your brain interprets. Okay, so for example, you are hearing my voice right now because the brain is interpreting where these vibrate, and it's putting that together into something meaningful. Okay, what you need to be aware of is this is all happening because of vibrations, so you don't want to interfere with the vibrations. For example, studies show, doctors recommend that you don't stick things that are smaller than your fist into your ear. Okay? So anything smaller than something, oh, that big, you shouldn't stick into your ear. Why is that? Your tympanic membrane is very small and very thin. If you stick something thin, like a needle or something like that, or an ear cleaner or a Q-tip, if you poke it, what you could do is you could make a hole in it. Now, there isn't supposed to be a hole in it, but you can make a hole in it, and that's very bad. If you make a hole in it, what's going to happen is the pressure waves are just going to go through that little hole. If they go through the little hole, the vibrations will not work as well. If the vibrations don't work as well, these vibrations here won't happen and it won't go to your brain. Now, that is what happens. This is what they do when they put tubes in little kids' ears, for example. But the tubes are designed so that they won't scar. If you just slice a hole in with your Q-tips, your body will grow it back, but you'll have scar tissue here. Now, if you've ever noticed scars on your hands or legs or whatever like that, they don't exactly blend in. The skin is different because it grew back different, it has more collagen, all that fun stuff, which means that it won't vibrate as well even after it's healed. Okay, now I know what you're saying, but Mr. Keeney, but what if my ears hurt? Right? Let's say you're driving to Kingman and you can feel that your ears need to pop. What that's happening is there's air in this area and it's at a different pressure and it's pushing out and it wants to get out. But it can't because your eardrum's in the way. There's a tube down here. This tube goes to your nose. Alright? Now, if you have a stuffy nose, it sucks. But that's why they tell you to chew gum, because if you chew gum, what's going to happen is it moves the muscles around in your face and it will help to open this tube so the pressure can escape this way. If you plug your nose when you sneeze, you have a potential of popping your ears. Okay, because the high pressure from the sneeze goes into your ears and it will build up here and it causes your ears to pop. And that's not good for you because the high pressure could rip through your eardrum and you might even see blood coming out of your ear because you just cut it. And that's bad. Alright, so this is why you don't pop your ears by plugging your nose, please. It's not good for you. Now, I know you're wondering what these semicircular canals are for. These are for maintaining your balance. Alright, you have one in your X, Y, and Z direction here. They're filled halfway with fluid. Alright, so what your brain does is your brain can feel, well, through your nerves, alright, that this area is fluid and this area is not fluid, so gravity is going down. Okay, now if you are upside down, it's going to be reversed, and it will figure out that gravity is going that way. Now, if you're spinning around a lot, what will happen is one ear will tell you that gravity is going that way, the other ear will tell you that gravity is going that way. Your brain gets confused because they should be pointing the same way, so that's what makes you feel dizzy. Now, why doesn't being dizzy go away immediately? Well, because think about it this way. The sides of your canals got splashed with fluid, and it takes a second for the water, it's not water, but you know what I mean, to settle. So that's what's happening, for the signals to die down. Anyways, we're going to talk a little bit about your cochlea here. So here's a zoomed in version if we sliced it open, right? This is just a segment, a cross-section of your nervous, of the snail shell-shaped thing. So you've got this wall here because that's to maintain the shape. And what happens is the waves are passing through this area, okay? So you've got a membrane that's connected to your nerve cell, and the nerve cell will go into there. Okay, does that make sense? And it's shaped this way to help focus the waves and keep track of everything. Now, in today's wondrous medical society, they can replace these in people to help deaf people to hear. Now, obviously, not every deaf person has a problem with their cochlea. Some have problems in other places. But it is possible to replace this to help people to hear. Okay, so this is how your hearing equipment that you came with, the ones that were pre-installed, that's how that works. So we're going to do a little practice combining this and the previous to help you understand how sound works.